Hello everyone, I'm Troy, and today I'm going to be talking to you about Cohen's D, specifically how to interpret it and how to apply it. So in order to understand the application of Cohen's D, it's important to understand the background as to why uh, people felt the need to use Cohen's D, a measure of effect size. And this comes down to practical versus statistical significance. So when we do a traditional hypothesis test, we are doing it to figure out whether or not that the results we're seeing were or that they're not due to random chance. So when we do a statistical test and we find that a significant result, we say that that result wasn't due to chance. So a significant a finding in a test doesn't necessarily mean a substantial treatment effect or practical significance. So to kind of illustrate this issue, I'm going to talk about some data I came up with regarding the effect of caffeine supplementation on the number of reps performed at 70% 1 rep max. So here we have a data set I created, n of 15 in each group. So to be able to figure out the effect of caffeine supplementation in this scenario, we create a control group, we create an experimental group. The control group is going to perform as many reps at 70% 1 RM as they can. They're not receiving any caffeine. The experimental group is going to do the same thing. They're going to perform as many reps as they can, but they took a caffeine supplement before. So we have the means, we have the standard deviations, we have the variances. The n in each group is 15. It's an independent samples we're going to run an independent samples t-test. We find that, running through some math here, we find the sum of squares, degrees of freedom. We get the pooled variance, and then finally we calculate the t-value, and we end up finding 1.5, and this was not enough to reach that t-critical value at the one-tailed test and an alpha level of 0.5. We find that we fail to reject this. We can't say that these results were due that they could not have been to chance. So we can't we don't have a significant result here. But we can, if we look at another data set, I'll move my big head out of the way here. Well, move my head out of the way here. That same thing, same data set, except now we're increasing the n. We're doubling the number of n, and we can see that same exact thing. I'm highlighting the differences here. We end up getting, just by changing the n value, we end up getting a t-value that allows us to reject. So now we reject the null hypothesis and say we have a significant result, when really all we did was change the number of subjects, and by changing the number of subjects, we were able to find statistical significance. Now the issue here is this is saying we have statistical significance, but what's the practical aspect of this? What's the magnitude of the difference between the means, the groups here? We don't know unless we do another calculation. And that's where a measure of effect size comes in. And the measure of effect size we're going to look at is Cohen's D. So Cohen's D, it's a effect size, measure of effect size, a quantitative measure of the magnitude for the difference of two means. So what we're doing is we're standardizing the difference between two means, this control group and the experimental group, and we're standardizing it in units of a pooled standard deviation. So from here, we use the same data that we used before for that 15 and 15 in each group. We do a calculation for Cohen's D, difference between the means, divided by a pooled standard deviation, and we end up getting an effect size of 0.71. So this says that the experimental group performed 0.71 more deviations higher than the control group. So if we follow these general conventions for effect sizes, this would lie in the range of a medium effect size. That there was a medium treatment effect of caffeine supplementation on the number of reps that these people were able to do at 70% of their 1 rep max. So a summary here, this underlies the practical significance. Sometimes we may not find statistical significance, especially in the field of exercise science, when we use small n, small samples, but we may still find practical significance. And one way to do that is to use Cohen's d that finds a deviation between two means and compares them in standard units of standard deviation.